All right, welcome back to Number Sense Academy. And in this video, we're going to talk about completing the square. So we're going to look at quadratic equations, and we're going to look at a method called completing the square. So this is quadratic equations, and we're looking at completing the square. And the idea there is we're going to generate an equation that is basically that has two factors that are the exact same. So a lot of times, in many situations, you won't be able to factor a quadratic equation, and there's rules and methods as to how to factor those or to actually get the zeros or the values. Um, in this particular case, what we're trying to do is if we're given a equation in standard form, so standard form looks something like y equals ax squared plus bx plus c. Completing the square allows us to convert standard form to vertex form. So we end up with y equals a times x minus 8 squared plus k. And even though the letters are kind of shifting, these represent different things. So the square component is here. This is where we the part that we're trying to square. And essentially, what that means is that we're trying to get our equation in, or trying to use this method so that we can take advantage of this fact that x squared plus 2ax plus a squared is equal to x plus 2 squared, or if we have x squared minus 2ax plus a squared, that's easily converted. Sorry, it shouldn't be. It's x minus a. Pardon me, right off the bat, making a mistake. X minus a squared. Okay, so that's what we want to take advantage of. We want to get this equation in these formats so that we can pull out the square part, and then obviously there'll be stuff in there that'll help us get the k and the a, and that's what we're gonna work through. So let's start with this. If I have x squared minus 6x minus 8. Now I can't factor this. If I'm going to go with conventional methods of factoring, I'm not going to find two numbers that multiply to negative 8 and add to negative 6. Okay? My only options would be negative 4 and 2. Okay, these are the numbers that I have. Well, these are my options. Negative 4 and 2, or negative 2 and 4. These, they do multiply to negative 8, but they don't add to negative 6. Right? And I know that negative 4 and negative 2 won't work because these, even though they add to negative 6, they don't multiply to negative 8. So we can't factor this per se. But here's the deal. The x squared, this part here, this part is part of a special product. And that special product is x squared minus 6x plus 9. Okay? There is a number that when squared, I get positive 9. And that same number, when summed to itself, we get negative 6. So that number is x, or that number is minus 3. So this becomes x minus 3 times x minus 3. And remember what we just showed. This is just x minus 3 squared. Okay? So why is this possible? Why can we do this? So let's just think for a second. If I have x equals 4, I could write this in many ways. I could write this as x minus 3 equals 1. Okay? I could write it as x is equal to 5 minus 1. I could write it as x plus 1 is equal to 4 plus 1. Okay? All of these still give me this value of 4. All of them. If I work out the algebra, I'm going to end up with 4 in all these cases. So basically, what this is telling me is that I can add whatever I want to my equation as long as I don't change the value of the equation. So I could actually have x squared minus 6x plus 9 minus 9 minus 8. These two values being here don't change the value because when I add them together, they actually don't, they're immaterial. They equal to 0. So therefore, what it allows me to do, it just allows me to change the expression of this equation. So what I end up with is, if I block off the values that belong to the product, so remember it's just going to be this part. So really what I end up with is x squared minus, well no, let me actually factor it. So I'm going to end up with x minus 3 squared minus 9 minus 8, which is x minus 3 squared minus 17. So now you already see that this is starting to look like what we're talking about with the y equals a times x minus 8 squared plus k. Right? This would be our k, and this would be our h. Simple as that. Okay, so we're going to use that idea, and then we're going to manipulate a few exercises to get the answer, or to complete the square. So, and as I do this, I will explain the rules that's associated. So let's start with this example. If I have x squared plus 2x minus 8. Okay, so I'm going to assume already that I can't factor this. So what I will do, I'm going to rewrite the equation so that I have x squared plus 2x is equal to 8. So I bring the negative 8 to the other side. Okay? And then now, what I'm going to do, I'm going to take a half of this, right? I'm going to take a half of this, and I'm going to square that. And where does that come from? Remember, x squared plus, in factored form, if I have x squared minus a squared, in expanded form, I have x squared minus 2ax plus a squared. Okay? So since we're ending up with a squared, right? If a is multiplied by 2 here, because remember we're going to subtract them twice, so we have to take a half of this. We take a half of this, and then we're going to square that. So I hope that makes sense. It's because of this is already has a factor of 2. Okay, if we were to put it in expanded form, this is being multiplied by 2. So whatever this value is being multiplied by 2. This value somewhere is being multiplied by 2. So then we have to take a half and then square that. So what we end up with is x squared. A half of 2 is 1, so we have 2x, and a half of 2 is 1, so 1 squared is just 1. Okay? And I'm going to put that in brackets right away. Now the other piece is that because this 1, I want to make it immaterial to the equation, because all I'm really doing is trying to change the expression, I'm going to subtract it. So now that's equal to 8. Okay? And then so I have x squared plus 2x plus 1 minus 1. And I'm going to bring the 8 back. So I have minus 8. And really, you don't even have to move the 8, but I'm just doing it so that we're clear that, one, it's a little bit cleaner to work with, and then we make sure that we remember that we have to do something with this -1, because I've forgotten several times, and your answer is wrong. So when I factor this part, I end up with x plus 1 squared, right? So this 1 is that half of this 2 squared, and then -1 minus 9 is -9 equal to 0. And we have this is in vertex form. Okay? We have it in vertex form. Great. So another example. So if I have x squared minus 8x minus 20, again, this is actually pretty straightforward. So I'm just going to do it all in one line. So I know that I have x squared. I'm taking a half of -8, which is -4. I'm keeping my -8. A half of -8, which is -4. And I'm going to square that. So -4 times -4 is 16. And I'm going to bracket this off right away. That's probably the easiest way so we don't mess this up. And then I know I'm going to minus 16. And then there's a minus 20 there. So what I end up with is x minus 4 squared, because it was half of the 8, half of the minus 8. And minus 16 and minus 20 is going to be minus 36. And that's it. Okay, let me do another example. And it's going to be 5x squared minus 10x plus 4. Okay, so this one's a little bit different, and it's because we now have a factor or a coefficient in front of the x squared. So we gotta take care of that. So what I end up with, I want to take out this 5. I want to take out the 5. Actually, you know what? This is where bringing the -4 to the other side helps. So if I have 5x squared minus 10x, I'm going to bring that to the other side. And the reason why I'm going to bring it there so I don't get it jumbled up. So this becomes -4. Okay? Now I'm going to factor out the 5, because 10 and 5 can accommodate 5. So I'm going to factor out 5. So I end up with 5 times x squared minus 2x. And that's equal to -4. All right. And then the next part is I'm going to do change this expression right here so that I can get it into a perfect square with an expanded form. So I'm going to take a half of -2, which is -1. So I'm minus 2x. And -1 times -1 is 1. All right? But, and I still have to subtract the 1. So this 1 gets subtracted here. So it's -1, and then equals -4. All right. So the trick here is that this -1 is a part of this. It's a part of this part of the expression. So I have to apply the factor to it. So I'm going to end up with 5 times x squared minus 2x plus 1 minus 5 equals -4. I'm not touching this 1 because that's part of a special product. Okay, I need that. So now, really what I'm working with the inside stuff for factoring. So I'm going to work with this. This is what I'm going to factor. So the way I'd write this is I'd have 5x minus 2x plus 1. And this minus 5 is just by itself. It's not being multiplied, so I'm going to have minus 5. And you know what, for good measure, I'm just going to bring the 4 back. It's a little bit redundant, but this is the way that I would do it to kind of keep things clean. And then I do my factoring, so I know this is x minus 1 squared, and then -5 plus 4 is going to be minus 1 equals 0. Right? And really and truly, you can try this out to see if you get the same answer. Like, what I mean by try it out, I mean like just do a quick test. So if I have 5x minus 1 squared, okay, I know it's going to be x squared minus 2x plus 1 minus 1 equals 0. If I expand this, I'm going to end up with 5x squared minus 10x plus 5 minus 1 equals 0. And then these 5 minus 1 like terms, so I end up with 5x squared minus 10x plus 4. So it gets me back exactly where I started, if you just want to do a quick check to see if you did it the right way. All right, another example. So what if I have 3y squared equals 3y plus 2? All right, so this is still a quadratic equation. Just because it's written this way, it's still a quadratic because there's this degree 2 there. So I'm going to do a bit of rearranging just to kind of begin solving this. So I'm going to write it as 3y squared minus 3y equals 2. So I'm going to keep the 2 away. It doesn't need to be pulled over yet. And then the next thing I'm going to do, I'm going to factor out a 3 because it's common to both of these. And I'm not taking out a negative 3 because I need y squared to be positive, but I'm going to take out a positive 3. So this becomes 3 times y squared minus y equals 2. Okay, and then I'm going to follow the same rule. So I'm going to take a half of the 1 that's in front of the y here. So I'm going to end up with y squared minus y. I'm going to take a half of the negative 1, which is negative 0.5, and I'm going to square that. So I'm going to end up with plus 0.25. And 3y squared minus y plus 0.25. And then remember, I need to subtract this 0.25. And then what I have is equal to 2. So what this works out to is, remember, this 3 gets applied to this negative 0.25. So what I end up with is 3 times y squared minus y plus 0.25. These are untouchable because this is where my perfect square comes from. And then I have minus 0.75. Okay, so that's already gone. The 3's already applied to this minus 0.75. I'm just going to bring the 2 over for good measure, just to keep it simple. So now I know I have 3 times y minus 0.5 squared, and then minus 0.75 minus 2 is equal to minus 2.75. And now I have something that's in perfect square format. And this is in Vertex Form. And that's it. Thank you.